What if I told you that our solar system has already been visited by travelers from the stars? Not spaceships, not aliens, but colossal wanderers, mysterious objects that were born in other star systems, flung across interstellar space, and then, by pure cosmic chance, passed right through our neighborhood. This isn't science fiction. In the last few years alone, astronomers have detected not one, not two, but 3 interstellar objects, 3 messengers from beyond, each one stranger than the last. And every time, we were left with more questions than answers. In this video, we're going to piece together everything we know about these cosmic intruders. We'll retrace the path of Oumuamua, the very first interstellar visitor that baffled scientists with its impossible shape and bizarre motion. Then, we'll dive into 2I, Borisov, a comet straight out of another star system, a visitor that looked familiar at first, but quickly revealed exotic differences. And finally, we'll explore the little-known but hauntingly important story of 3I, Atlas, the third interstellar traveler that slipped through our system and is now fading into eternal darkness. Each of these objects carries secrets about how stars and planets form, and perhaps clues about the conditions for life beyond our sun. But as we'll see, the closer we look, the stranger these visitors become. So, buckle up, because this story isn't just about rocks and ice drifting through space. It's about confronting the unknown, the realization that our solar system is not isolated, but part of a much larger, more mysterious galaxy. A galaxy that sometimes sends us reminders of just how little we truly understand. The year was 2017. Astronomers at the Pan-STARRS-1 telescope in Hawaii were scanning the skies, cataloging asteroids and comets, when they noticed something strange. An object had appeared in their survey moving too fast, on too sharp a trajectory, to belong to our solar system. It was quickly given the designation 1I, meaning the first interstellar object ever observed. Soon after, it was nicknamed Oumuamua, a Hawaiian word meaning scout or messenger from afar, and the name could not have been more fitting. What made Oumuamua immediately fascinating was its speed and orbit. Unlike normal asteroids, which loop around the sun in predictable ellipses, this thing was barreling through space on a hyperbolic trajectory. It came from somewhere outside the solar system, swung around the sun, and then kept going, never to return. But speed wasn't the only mystery. As telescopes around the world zeroed in, they realized that Oumuamua didn't look or behave like anything we'd ever seen before. When astronomers tried to model its light curve, the way it reflected sunlight as it spun, they discovered something mind-bending. Oumuamua seemed to be elongated to an extreme degree. Depending on the interpretation, it was either shaped like a cigar, long and thin, perhaps 800 meters by 80 meters, or like a pancake, flat and wide, unlike any asteroid or comet ever seen. In our solar system, natural bodies tend to be more rounded, or at most irregularly shaped, like potatoes. But this thing looked almost engineered. Its brightness changed by a factor of 10 as it tumbled, suggesting a wildly stretched out geometry. Even stranger, when scientists tracked its motion, they realized it was accelerating slightly as it left the solar system. This shouldn't have been possible. Normally, an asteroid follows gravity's pull exactly. But Oumuamua was behaving like a comet, except there was no visible coma, no tail, no jets of gas to explain the push. Theorists scrambled for explanations. Some suggested maybe it was made of a type of exotic ice that sublimates invisibly. Others proposed it was a shard of a larger body, torn apart by some cosmic cataclysm. And then came the most controversial idea. Maybe, just maybe, this wasn't a natural object at all. In 2018, Harvard astronomer Avi Loeb made headlines by proposing that Oumuamua could be an artificial probe, a fragment of alien technology, perhaps a thin solar sail drifting between the stars. His reasoning was simple. Its strange shape, lack of visible outgassing, and unexplained acceleration all fit awkwardly with natural explanations, but could be explained if it were a thin sheet designed to harness starlight. The idea sparked debate across the scientific community. Most astronomers argued for natural explanations, perhaps hydrogen ice evaporating invisibly, or a fluffy fragment of a disrupted planetesimal, but none of these theories fully fit the data. To this day, Oumuamua remains a riddle. Was it a bizarre shard of rock and ice, shaped in some alien star system and flung into space? Or was it something truly extraordinary, a messenger not just from another system, but from another intelligence? One thing is certain, we spotted it far too late. By the time telescopes were trained on it, Oumuamua was already racing away, fading into the black. We may never know the truth. And yet, its visit changed everything. For the first time, we had proof. Objects from other star systems do pass through ours. But the strangest thing wasn't just its speed, it was its trajectory. Most comets and asteroids we track follow predictable orbits, tugged gently by the sun's gravity. But Oumuamua did something different, something that shocked astronomers. As it slingshotted around the sun, it accelerated slightly, as if some invisible hand had given it a push. Normally, that kind of acceleration comes from a comet, when heat from the sun causes ice to sublimate, shooting out jets of gas that act like tiny rocket engines. But Oumuamua didn't have the fuzzy halo or long tail of a comet. In fact, telescopes saw no visible outgassing at all. It looked like a rock, but it moved like a comet. This paradox split the scientific community. Some researchers suggested maybe it was made of exotic ices we hadn't seen before, like solid hydrogen or nitrogen, which could evaporate without leaving much of a visible trail. Others thought maybe it was a fractured shard from a larger body, ejected at incredible speeds from another star system. But then came a bolder idea, one that lit up headlines across the world. In late 2018, Harvard astronomer Avi Loeb proposed something radical. What if Oumuamua wasn't natural at all? What if it was a piece of alien technology, perhaps a light sail, a thin sheet pushed by starlight drifting through space? The strange shape, the unexplained acceleration, the lack of a visible comet tail, all of it could, he argued, point to something artificial. The idea sparked controversy. Many scientists dismissed it, saying the alien hypothesis should only be a last resort. But the fact remains, we still don't fully know what Oumuamua was. We only had 11 days of good observation before it became too faint to track. And by the time telescopes turned back to it, it was already disappearing into the black, never to return. By early 2018, it had already faded beyond detection. And today, in 2025, it's out there, millions of kilometers away, silently drifting between the stars. We'll never see it again. But the legacy of Oumuamua is bigger than the object itself. It forced us to admit something humbling. Interstellar visitors aren't just possible, they're real. And if one could wander through our solar system, more would follow. Oumuamua reminded us that the universe is not just a backdrop to our existence. It's active, dynamic, and sometimes downright puzzling. In that moment, humanity realized we're not isolated. Our solar system is open, objects from other stars can and do pass through. And indeed, just 2 years later, another arrived, one that was less mysterious but equally extraordinary. A visitor that confirmed once and for all that interstellar objects were not rare accidents but part of a larger, hidden story about the movement of matter across the galaxy. This was 2I, Borisov, the first confirmed interstellar comet. When Oumuamua was first spotted, scientists debated for months about what it really was. But 2 years later, in August 2019, another discovery silenced the skeptics. A Ukrainian amateur astronomer named Gennady Borisov noticed a strange fuzzy object while scanning the skies through his homemade 0.65-meter telescope in Crimea. Unlike the sharp, point-like reflection of a star, this object had a blurry tail, a sure sign of a comet. At first, people assumed it was just another icy wanderer from the Oort cloud or the far reaches of our solar system. But orbital calculations quickly shattered that idea. The object's path was hyperbolic, not bound to the sun. Its eccentricity was measured at 3.36, far beyond anything a solar system comet could achieve. This meant it wasn't looping around the sun, it was just passing through. And with that, humanity confirmed its second interstellar visitor, 2I Borisov. Unlike Oumuamua, which remained mysterious because of its lack of a tail, 2I Borisov was comfortingly familiar. A comet complete with a glowing coma, and a long dust tail stretching thousands of kilometers. But familiarity doesn't mean ordinary. As astronomers began to examine it using the Hubble Space Telescope and observatories on Earth, they realized Borisov was far more pristine than any comet we had ever seen. You see, comets in our solar system have made multiple passes by the Sun. Each time, they lose material, burn off ice, and leave behind a weathered, scarred body. But Borisov? It had spent billions of years drifting in the deep freeze of interstellar space, untouched, unaltered. It was like holding a time capsule from another star system. By breaking down the light coming from its coma, astronomers discovered something unexpected. Borisov was loaded with carbon monoxide. In fact, it had levels of CO gas at least 10 times higher than the average solar system comet. This suggested it was born in an extremely cold environment, possibly on the icy outer edges of another solar system, far beyond the equivalent of our Kuiper belt. This raises a fascinating possibility. Maybe Borisov formed in a system where the star was dim, or maybe it was ejected from a newborn solar system where frozen materials were abundant. Whatever the case, Borisov gave us direct proof that other planetary systems create comets, just like ours do, and possibly in even more extreme forms. As Borisov got closer to the Sun, something dramatic happened. In March 2020, astronomers detected that it was breaking apart. Its nucleus, estimated to be between 400 meters and 1 kilometer across, was splitting into pieces. This wasn't unusual for comets in general. We've seen plenty of local ones crack under the stress of sunlight and internal gas pressure. But with Borisov, this moment felt almost tragic. Here was an ancient traveler from another star, billions of years in the making, only to crumble into dust during its one brief encounter with us. Still, that breakup gave astronomers a closer look at its structure. They confirmed it was made of fragile, porous ice and dust, just like the comets we know. But the higher abundance of carbon monoxide hinted at different environmental conditions in its home system. While Oumuamua left us with more questions than answers, Borisov gave us clarity. It confirmed that comets' icy leftovers of planet formation are not unique to our solar system. Other stars also form them, and sometimes their gravity slingshots them into interstellar space, sending them drifting endlessly until they pass through places like ours. Borisov also gave us a benchmark. Astronomers estimate that billions of such interstellar comets are drifting through the galaxy at any given moment. The fact that we found 2 in just 3 years, Oumuamua in 2017, Borisov in 2019, suggests that with better surveys and telescopes, we may spot them regularly. In fact, the upcoming Vera Rubin Observatory in Chile, set to begin operations soon, will scan the entire night sky every few nights with unmatched sensitivity. Scientists predict it could detect dozens or even hundreds of interstellar visitors over the coming decades, and each one will carry secrets from its home system. If Oumuamua was a riddle, Borisov was reassurance. It proved that the galaxy is filled with wandering remnants of other solar systems, and by studying them, we can understand how planets form across the Milky Way. But the story doesn't end there. Just 5 years later, on July 1, 2025, we spotted a third one, 3I Atlas. And unlike the previous 2, its fate was short-lived, dramatic, and even more mysterious. That's what we'll explore next. When astronomers announced in 2019 that another interstellar object had been spotted just 2 years after Oumuamua, the world was shocked. Statistically, the odds of catching one of these cosmic passers-by are slim. To find 2 in such quick succession suggested something profound. Maybe these visitors aren't as rare as we once thought. And then came whispers of a third, an object that promised to rewrite the story once again. This one was cataloged as C, 2019 Q4 Borisov, but later discussions began circling around a potential third interstellar candidate, 3I Atlas. Unlike Oumuamua's brief, enigmatic flyby, or Borisov's unmistakable cometary display, Atlas's identity was more complicated. Some data hinted at interstellar origins, but its trajectory and brightness raised questions. Was this truly an alien visitor, or just a long-period comet from the far reaches of our own Oort cloud? At the time of discovery, 3I, Atlas, was about 4.5 astronomical units, around 670 million kilometers away from the Sun. Wired. Its orbit is highly hyperbolic, with an eccentricity of approximately 6.1, far exceeding those of Oumuamua and Borisov, confirming its undeniably interstellar trajectory. Perihelion, the point of closest solar approach, on October 29-30, 2025, at about 1.38 AU, roughly 206 million kilometers, just inside Mars's orbit. As it neared perihelion, the comet's speed surged, clocking in at about 68 kms relative to the Sun, while its interstellar inbound speed was near 58 kms. Early estimates put the size of 3I, Atlas, at up to 20 kilometers in diameter, but subsequent observations refined that drastically. The Vera C. Rubin Observatory suggested 10 kilometers, and later the Hubble Space Telescope constrained the nucleus to no more than 5.6 kilometers, possibly as small as 0.32 kilometers, 320 meters. Hubble's July 21, 2025 image captured a teardrop-shaped coma dust enveloping an icy nucleus, emphasizing its active nature. The debate itself was a turning point. Atlas showed us just how challenging it is to draw the line between interstellar and local. When we watch an object move against the background of stars, tiny errors in calculation can make the difference between calling it one of our own or declaring it a messenger from another system. And this uncertainty revealed the limits of our telescopes, our models, and even our imagination. Unlike Oumuamua, which appeared as a faint streak of light and then vanished, or Borisov, which screamed comet with its glowing coma, Atlas seemed to blur categories. Some astronomers proposed that it could be an interstellar comet with a broken or fragmented nucleus, shedding material too faint for most instruments to clearly detect. Others argued it was more likely a homegrown comet from the extreme outskirts of the solar system. Not exotic, just unusual. This ambiguity mattered because every confirmed interstellar object is more than just a rock. It's a messenger, a fragment of another star's history, ejected long ago, now drifting into our neighborhood. To confirm or deny Atlas's status was, in a sense, to decide whether humanity had truly glimpsed 3 of these messengers in less than a decade. Think about it. 3 interstellar objects in under 10 years. Before 2017, the count was 0. For centuries, humanity looked up at the stars, imagining visitors from other systems, but never once confirmed that any had arrived. Then suddenly, they came in waves. Even if Atlas remains uncertain, its candidacy proves something important. We are now watching closely enough to notice. Our sky surveys are better, faster, and more global than ever before. Projects like Pan-STARRS in Hawaii, Atlas itself, and soon the Vera C. Rubin Observatory in Chile will make it nearly impossible for another Oumuamua to slip by unnoticed. In fact, some astronomers predict we may discover dozens, perhaps hundreds, of interstellar objects in the coming decades. Each one is a sample, a free delivery across light years. Instead of waiting for probes to crawl out to the nearest stars, journeys that could take tens of thousands of years, the galaxy is sending us fragments to study. Here's the exciting part. We no longer just want to observe these objects. We want to catch them. NASA and ESA scientists are already designing interceptor mission spacecraft, ready to launch at a moment's notice, waiting on Earth for the next interstellar visitor. Imagine, an object is spotted rushing through the solar system. Within months, a probe is launched, racing to intercept, photograph, and even sample the material of another star's wanderer. If we succeed, we won't just be looking at light curves and blurry telescope images. We'll be holding alien dust in our hands, dust that once swirled around another sun, possibly from a planet that no longer exists, or a system very different from ours. That's the scale of discovery at stake here. So, What do Oumuamua, Borisov, and Atlas ultimately mean for us? Together, they paint a picture of a galaxy alive with movement. Planets form and shatter. Stars tug at comets and fling them into the abyss. For every system like ours, there may be countless fragments drifting between the stars, waiting to be found. Oumuamua reminded us of mystery, that not everything in the universe fits neatly into categories. Borisov reminded us of familiarity, that the processes shaping our solar system happen everywhere. And Atlas reminded us of humility, that the line between the known and unknown is thinner than we think. Together, they whisper a message across the void. We are not isolated. We are part of a galactic ecosystem, constantly exchanging material, ideas, and perhaps one day, life itself. When you look up tonight, remember, beyond the planets, beyond the stars, wanderers are passing through, silent and unseen. Some have already visited us, leaving behind more questions than answers. Others are on their way, racing across the light years, destined to brush against our sun before vanishing again into eternity. And maybe, just maybe, the next interstellar object we find won't just be a faint streak of light in the sky. Maybe it will be the first true bridge between our world and another.